This is exam 1, number 3. So number 3 says, if f of x equals sine squared of 3 minus x, what is the value of the derivative of f evaluated at 0? Okay, so let's just find the derivative of f of x and then evaluate it at 0. Look at what f of x is. Did you know that the sine squared of 3 minus x is the same as the sine of 3 minus x squared? That's what it means. So there are really 3 different functions that have been composed to create f. One of the functions is like u squared. Inside of that function is just the sine of u. And inside of that function is the function 3 minus x. We'll need to use the chain rule to take the derivative of the whole thing. So to begin with, we take the derivative of this outside function, which will become 2 times the sine of 3 minus x, and then the 2 minus 1 is 1, so it's all of this to the first power, or the sine of the 1, but we don't need to write that. We do need to multiply this now times the derivative of the inside function. This is using the chain rule. So we're looking for the derivative of the sine of 3 minus x. The derivative of the sine is the cosine. So it's the cosine of 3 minus x. But we're not done. We have to now apply the chain rule again and take the derivative of 3 minus x. The derivative of 3 is 0. This minus x is like plus a negative 1x, and the derivative of that is just negative 1. So to pull it all together, we can multiply the 2 and the negative 1. We get negative 2 times the sine of 3 minus x times the cosine of 3 minus x. This is what the derivative of f of x equals. It's not what the question is asking. It's asking what is the value of this derivative evaluated at 0. So to do that, we'll just replace all the x's now in this derivative with a 0. So the derivative of f at 0 is negative 2 times the sine of 3 minus 0 times the cosine of 3 minus 0. Okay, we can clean it up a little bit more. This is negative 2 times the sine of 3 times the cosine of 3. If you would have typed that all out into the calculator and come up with a decimal, I would have given you credit, but really this is enough. This is the derivative of f evaluated at 0.